Tab dividers can be used to divide the National Electrical Code into sections such as articles and chapters. Label each tab with the corresponding section for quick and easy access. Consider using heavy-duty tabs to ensure durability. Bookmarks can be inserted into the relevant pages or sections for future reference. Use different colors or types of bookmarks to categorize different topics, such as important articles, code changes, and notes. Mark the top of each bookmark with a visible tab for easy retrieval. Highlighters and sticky notes are other options. Highlight important sections or articles with highlighters in different colors to differentiate them. Use sticky notes to mark specific paragraphs, formulas, or codes that require attention. Consider using low-profile sticky notes to minimize bulk and avoid obscuring text. Digital note-taking tools can be useful. Utilize digital note-taking apps to create electronic notes and annotations within the National Electrical Code portable document format. Use keywords and tags to categorize and search for specific information. Sync notes across devices for easy access. Consider custom indexes. Create a custom index in the front or back of the National Electrical Code. List important articles, code changes, or topics along with their corresponding page numbers. Keep the index updated as new information is added. There are also specialized organizers to invest in. Invest in specialized National Electrical Code organizers that provide pre-designed dividers, tabs, and marking systems specifically tailored to the National Electrical Code. These organizers can offer additional features such as pockets for documents or power cords. Foldable page flags can be used to mark specific pages that you want to quickly access or reference. Use post-it tabs with arrows or labels to create custom tabs on specific pages or sections. Laminated inserts can be created with important information or code changes and then inserted them into the National Electrical Code at relevant locations. Proper organization will enable quick and easy reference to critical information within the National Electrical Code. This, in turn, improves efficiency, reduces errors, and facilitates compliance with electrical safety standards. When organizing a National Electrical Code, there are many factors to keep in mind. Firstly, identify the specific requirements. Electrical codes typically address various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, equipment installation, and safety requirements. It is essential to identify the specific requirements relevant to the project or task at hand. Secondly, become familiar with the code structure. Electrical codes are usually organized into chapters, articles, and sections, each covering a specific topic or aspect of electrical installations. Take time to understand the code structure to navigate it effectively. Thirdly, understand the terminology used. Electrical codes use technical terms and definitions that may not be familiar to everyone. Familiarize yourself with the commonly used terms and definitions to interpret the code accurately. Fourthly, pay attention to tables and diagrams. Electrical codes often include tables and diagrams that provide essential information such as conductor ampacity, conduit fill, and equipment clearances. Pay close attention to these visual aids to ensure compliance with the code requirements. Fifthly, understand the purpose of each requirement. Electrical codes are developed to ensure the safety of people and property. Understanding the purpose behind each requirement can help interpret and apply the code effectively. Sixthly, consult with experts. If unsure about any aspect of the electrical code, consult with qualified electrical engineers, inspectors, or other experts who can provide guidance and clarification. Seventhly, stay up to date. Electrical codes are periodically updated to reflect changes in technology, industry practices, and safety standards. Stay informed about the latest code revisions and amendments to ensure compliance with the most current requirements. Eighthly, document all decisions. Keep a record of all decisions and interpretations made regarding the electrical code. This documentation can be helpful for future reference, inspections, and audits. Ninthly, use code-compliant products. Only use electrical products and equipment that are listed or labeled by a recognized testing laboratory. This ensures that the products meet the applicable safety standards and code requirements. 10thly, follow manufacturer's instructions. Install and use electrical products and equipment according to the manufacturer's instructions. This helps ensure that the products perform as intended and comply with the code requirements. The National Electrical Code, also known as the NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. While it is not law itself, it is often adopted by state and local jurisdictions, making it a legal requirement. Understanding the NEC is crucial for electrical contractors, engineers, inspectors, and anyone involved in electrical work. Firstly, the scope of the NEC covers electrical conductors and equipment installed within or on public and private buildings and other structures, including mobile homes, recreational vehicles, and floating buildings. It also covers the installation of optical fiber cables in raceways. Secondly, the NEC does not cover installations in ships, watercraft other than floating buildings, railway rolling stock, aircraft, or automotive vehicles. It also does not cover underground mining installations or installations under the exclusive control of an electric utility for the purpose of communication, metering, or generating, controlling, transforming, transmitting, and distributing power. Thirdly, the NEC is organized into chapters, articles, and sections. Chapters cover broad topics such as general requirements, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions. Articles cover more specific topics within each chapter. Sections provide detailed requirements for specific installations or equipment. Fourthly, some of the key requirements in the NEC include grounding and bonding. Grounding is the connection of electrical equipment to the earth to provide a path for fault current to flow back to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. Bonding is the connection of metallic parts of an electrical system to create a low impedance path for fault current. Overcurrent protection involves circuit breakers and fuses that are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are reusable devices that trip when the current exceeds a certain level, while fuses are one-time devices that melt and open the circuit when the current exceeds a certain level. Wiring methods and materials specifies the types of wiring methods and materials that are permitted for different applications. It covers conductors, cables, raceways, and other wiring components. Equipment installation requirements specify the requirements for installing electrical equipment such as receptacles, switches, lighting fixtures, and appliances. It covers mounting, wiring, and grounding requirements. Safety requirements specify the safety requirements for electrical installations such as arc fault circuit interrupters, ground fault circuit interrupters, and surge protective devices. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults, while ground fault circuit interrupters are designed to protect against electric shock caused by ground faults. Surge protective devices are designed to protect against voltage surges caused by lightning or other events. Fifthly, the NEC is updated every 3 years. The National Fire Protection Association, or NFPA, which publishes the NEC, updates the code every 3 years to reflect changes in technology, industry practices, and safety standards. The latest edition of the NEC is the 2023 edition. Sixthly, compliance with the NEC is essential for ensuring the safety of electrical installations. Failure to comply with the NEC can result in electrical shocks, fires, and other hazards. It can also result in fines, penalties, and legal liability. The National Electrical Code, NEC, is a comprehensive set of standards for electrical installations. To effectively navigate and utilize the NEC, it's helpful to understand its structure, key articles, and how to apply it in practical scenarios. Here is a breakdown. Firstly, the NEC is organized into chapters, articles, parts, and sections. Chapters cover broad categories like general requirements, wiring and protection, wiring methods, equipment for general use, special occupancies, special equipment, and communication systems. Secondly, articles delve into specific topics within each chapter, providing detailed requirements and guidelines. Thirdly, parts further refine the requirements within an article, offering clarity on specific aspects of the topic. Fourthly, sections of the most granular level, containing specific rules and regulations. Key articles within the NEC address fundamental aspects of electrical installations. Article 90 covers the introduction to the NEC, its purpose, scope, and enforcement. Article 100 defines essential terms used throughout the code, ensuring clear understanding and consistent application. Chapter 2, specifically Articles 210, 220, and 230, focuses on wiring and protection. Article 210 covers branch circuits, detailing requirements for conductor sizing, overcurrent protection, and receptacle placement. Article 220 addresses calculations for feeder and service loads, providing methods to determine the appropriate size of conductors and equipment. Article 230 covers services, outlining the requirements for the connection of electrical power from the utility to the building or structure. Chapter 3 covers wiring methods and materials, and includes Articles 300, 310, and 314. Article 300 addresses general requirements for wiring methods, including installation techniques and protection against physical damage. Article 310 covers conductors for general wiring, specifying the types of conductors, their ampacity, and conditions of use. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures, providing requirements for their installation and use. Chapter 4 focuses on equipment for general use, and includes Articles 400, 406, and 408. Article 400 covers flexible cores and cables, detailing their permitted uses, construction, and ampacity. Article 406 covers receptacles, cord connectors, and attachment plugs or cord sets, outlining the requirements for their installation and use. Article 408 covers switchboards, switchgear, and panel boards, providing requirements for their construction, installation, and overcurrent protection. Chapter 5 addresses special occupancies, and includes Articles 500, 517, and 547. Article 500 covers hazardous, classified locations, specifying the requirements for electrical equipment and wiring in areas where flammable gases, vapors, or dust may be present. Article 517 covers healthcare facilities, providing additional requirements for electrical systems in hospitals, clinics, and other healthcare settings. Article 547 covers agricultural buildings, addressing the specific electrical needs and safety considerations for agricultural structures. To effectively apply the NEC, firstly, determine the scope of the project. Identify the type of electrical installation, its location, and any specific conditions that may affect the design and installation. Secondly, review the relevant articles and sections. Consult the NEC to identify the articles and sections that apply to the project. Pay close attention to the specific requirements and guidelines provided. Thirdly, perform calculations. Calculate the required conductor sizes, overcurrent protection, and equipment ratings based on the load requirements and applicable NEC tables. Fourthly, select appropriate wiring methods and materials. Choose wiring methods and materials that are suitable for the environment and meet the NEC requirements. Fifthly, install equipment correctly. Install electrical equipment according to the manufacturer's instructions and the NEC requirements. Ensure proper grounding, bonding, and overcurrent protection. Sixthly, inspect and test the installation. After completing the installation, inspect and test the system to verify that it meets the NEC requirements and is safe to operate. The NEC contains various tables that provide essential information for electrical installations. Understanding how to use these tables is crucial for selecting the right components and ensuring compliance with the code. Here's a guide to some of the most important tables. Firstly, Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. Ampacity refers to the maximum current, in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. This table is used to determine the appropriate size of conductors based on the amount of current they will carry. Factors such as the conductor's insulation type, ambient temperature, and the number of current-carrying conductors in a raceway or cable affect the ampacity. Secondly, Table 310.15b3 provides adjustment factors for ambient temperature. These factors are used to adjust the allowable ampacity of conductors when ambient temperature is higher than 30 degrees Celsius or 86 degrees Fahrenheit. High ambient temperatures reduce the ability of conductors to dissipate heat, so their ampacity must be reduced to prevent overheating. Thirdly, Table 310.15b3 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. When multiple current-carrying conductors are installed in the same raceway or cable, the heat generated by each conductor can raise the overall temperature, reducing the ampacity of each conductor. This table provides adjustment factors to account for this effect. Fourthly, Table 220.42 provides demand factors for feeders and services. Demand factors are used to reduce the calculated load on feeders and services based on the assumption that not all connected loads will operate simultaneously at their maximum rating. This table provides demand factors for various types of loads such as lighting, receptacles, and appliances. Fifthly, Table 250.122 provides the minimum size of equipment grounding conductors for grounding raceway and equipment. Equipment grounding conductors, also known as EGC, are used to provide a low impedance path for fault current to flow back to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. This table provides the minimum size of EGC based on the rating of the overcurrent protective device protecting the circuit. Sixthly, Table 430.250 provides the full load current of alternating current single-phase motors. This table is used to determine the full load current of single-phase motors based on their horsepower and voltage rating. The full load current is used to calculate the required conductor size and overcurrent protection for the motor circuit. Seventhly, Table 430.251 provides the full load current of alternating current three-phase motors. This table is used to determine the full load current of three-phase motors based on their horsepower and voltage rating. The full load current is used to calculate the required conductor size and overcurrent protection for the motor circuit. To use these tables effectively, firstly, identify the relevant table for the specific application. Secondly, determine the appropriate parameters for the table, such as conductor type, ambient temperature, number of conductors, load type, and equipment rating. Thirdly, locate the corresponding value in the table based on the identified parameters. Fourthly, apply any necessary adjustment or correction factors as indicated in the table notes. Fifthly, use the table value to select the appropriate conductor size, overcurrent protection, or equipment rating. The NEC contains requirements for grounding and bonding to ensure electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects metallic parts of an electrical system to create a low impedance path for fault current. Grounding and bonding work together to minimize the risk of electric shock and fire hazards. Firstly, grounding involves connecting electrical equipment and systems to the earth through a grounding electrode. The grounding electrode provides a low impedance path for fault current to flow back to the source. The grounding electrode must be a metal rod, pipe, or plate that is buried in the earth. Secondly, bonding involves connecting metallic parts of an electrical system to create a continuous electrical path. Bonding ensures that all metallic parts are at the same electrical potential, minimizing the risk of electric shock. Bonding is typically achieved by using bonding jumpers to connect metallic parts together. Key NEC articles related to grounding and bonding are: firstly, Article 250 covers grounding and bonding requirements. This article provides detailed requirements for grounding electrodes, grounding conductors, equipment grounding conductors, and bonding jumpers. Secondly, Article 250.4 provides general requirements for grounding and bonding. This section specifies the requirements for grounding electrical systems, equipment, and enclosures. Thirdly, Article 250.24 provides requirements for grounding separately derived systems. This section covers the grounding requirements for generators, transformers, and other separately derived systems. Fourthly, Article 250.50 provides requirements for grounding electrode systems. This section specifies the requirements for grounding electrodes, including their type, size, and installation. Fifthly, Article 250.92 provides requirements for bonding service equipment. This section covers the bonding requirements for service equipment, such as service enclosures, meter sockets, and grounding electrode conductors. Sixthly, Article 250.96 provides requirements for bonding other enclosures. This section covers the bonding requirements for enclosures that contain electrical equipment, such as junction boxes, panel boards, and disconnect switches. To ensure proper grounding and bonding, firstly, install a grounding electrode system that meets the NEC requirements. The grounding electrode system should consist of a metal rod, pipe, or plate that is buried in the earth. Secondly, connect the grounding electrode to the electrical system using a grounding electrode conductor. The grounding electrode conductor should be sized according to NEC Table 250.66. Thirdly, bond all metallic parts of the electrical system together using bonding jumpers. Bonding jumpers should be sized according to NEC Table 250.102. Fourthly, ensure that all equipment is properly grounded. Equipment grounding conductors should be connected to the equipment grounding terminal in the equipment enclosure. Fifthly, inspect and test the grounding and bonding system to verify that it meets the NEC requirements. The NEC specifies requirements for overcurrent protection to protect electrical circuits and equipment from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. Overcurrent protection is essential for preventing electrical fires and equipment damage. Firstly, overloads occur when the current in a circuit exceeds the ampacity of the conductors. Overloads can be caused by excessive loads on the circuit, such as too many appliances plugged into a receptacle. Secondly, short circuits occur when there is a direct connection between two conductors of different potential. Short circuits can be caused by damaged insulation, loose connections, or faulty equipment. Key NEC articles related to overcurrent protection are: firstly, Article 240 covers overcurrent protection requirements. This article provides detailed requirements for circuit breakers, fuses, and other overcurrent protection devices. Secondly, Article 240.4 provides requirements for protection of conductors. This section specifies the requirements for protecting conductors from overcurrent. Thirdly, Article 240.6 provides standard ampere ratings for fuses and inverse time circuit breakers. This section lists the standard ampere ratings for overcurrent protection devices. Fourthly, Article 240.21 provides location requirements for overcurrent protection devices. This section specifies the requirements for locating overcurrent protection devices in electrical systems. Fifthly, Article 240.80 provides requirements for overcurrent protection of motor circuits. This section covers the overcurrent protection requirements for motor circuits. To ensure proper overcurrent protection, firstly, select overcurrent protection devices with the appropriate ampere rating. The ampere rating of the overcurrent protection device should be based on the ampacity of the conductors and the load requirements of the circuit. Secondly, install overcurrent protection devices in readily accessible locations. Overcurrent protection devices should be installed in locations where they can be easily accessed for maintenance and replacement. Thirdly, protect conductors from overcurrent. Conductors should be protected from overcurrent by overcurrent protection devices that are sized according to the NEC requirements. Fourthly, protect motor circuits from overcurrent. Motor circuits should be protected from overcurrent by overcurrent protection devices that are sized according to the NEC requirements for motor circuits. Fifthly, inspect and test overcurrent protection devices to verify that they are functioning properly. Overcurrent protection devices should be inspected and tested periodically to ensure that they will trip when an overcurrent occurs. The NEC outlines requirements for wiring methods and materials to ensure safe and reliable electrical installations. Wiring methods refer to the techniques and materials used to install electrical conductors, while wiring materials refer to the conductors, cables, raceways, and other components used in electrical wiring systems. Firstly, conductors are the wires that carry electrical current. Conductors are typically made of copper or aluminum and are insulated to prevent electrical shock. Secondly, cables are assemblies of two or more conductors that are enclosed in a protective sheath. Cables are used to distribute power to various parts of a building. Thirdly, raceways are enclosed channels that are used to protect and route electrical conductors. Raceways can be made of metal, plastic, or other materials. Key NEC articles related to wiring methods and materials are: firstly, Article 300 covers general requirements for wiring methods and materials. This article provides general requirements for the installation of conductors, cables, and raceways. Secondly, Article 310 covers conductors for general wiring. This article specifies the types of conductors that are permitted for different applications, their ampacity, and conditions of use. Thirdly, Article 312 covers cabinets, cut-out boxes, and meter socket enclosures. This article provides requirements for the construction, installation, and use of cabinets, cut-out boxes, and meter socket enclosures. Fourthly, Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. This article provides requirements for the construction, installation, and use of outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. Fifthly, Article 320 covers armored cable type AC. This article specifies the requirements for armored cable type AC, including its construction, installation, and use. Sixthly, Article 330 covers metal-clad cable type MC. This article specifies the requirements for metal-clad cable type MC, including its construction, installation, and use. Seventhly, Article 334 covers non-metallic sheet cable types NM, NMC, and NMS. This article specifies the requirements for non-metallic sheet cable types NM, NMC, and NMS, including their construction, installation, and use. To ensure proper wiring methods and materials, firstly, select conductors, cables, and raceways that are suitable for the application. The selected wiring methods and materials should be based on the voltage, current, and environmental conditions of the installation. Secondly, install conductors, cables, and raceways according to the NEC requirements. Conductors, cables, and raceways should be installed in a neat and workmanlike manner and should be supported and secured properly. Thirdly, protect conductors and cables from physical damage. Conductors and cables should be protected from physical damage by using raceways, enclosures, or other protective measures. Fourthly, ground all metallic enclosures and raceways. Metallic enclosures and raceways should be grounded to provide a path for fault current to flow back to the source. The National Electrical Code is essential for designing electrical systems that meet safety and performance standards. Using it effectively requires a thorough understanding of its structure, tables, and requirements. Staying up to date with the latest edition of the NEC is also crucial for ensuring compliance and safety.